At the very beginning of this chapter, I mentioned that there were two main ways we had of combining functions so that we could build new functions out of old ones. The first was arithmetic, and we spent a good bit of time with that because there are 4 arithmetic operations, so we can add, subtract, multiply, and divide. Okay. We're ready now to look at the second main way we have, which is function composition. The notation for that can be one of 2 things. F of g, which is how we would read that. This is f of g of x. Okay, so that's f of g of x. Okay, is what we would write if we wanted to give the function just a single name. This notation here I find much more helpful. Okay, it's f, and then inside of parentheses you've got g, and inside another set of parentheses you have x. Remember, when we're evaluating a function, whatever's inside the parentheses after the name of the function is what you're plugging into that function. So function composition is going to be where we take x, we plug it into g, whatever we get out from there is going to become the input to f. So it's sort of like an assembly line process where you take your initial input, you give it to g, it does something, passes it on, and then f does something to that number rather than to the initial input x. Now, the notation often gets confused with the notation for multiplication, which is very different. So I've written that up here. If we're multiplying 2 functions, if we want to give the product function just a single name, we call it fg. We would put that in parentheses to indicate that that's one thing, and then of x. And what that means, of course, is we evaluate that piecewise, so it's f of x times g of x. Notice the same thing is being plugged into f as is being plugged into g. Okay. So let's just compare these two. Let's let f of x equal x squared, and let's let g of x be x plus 2. Okay. Now, if I wanted to evaluate the product function, fg at, let's say, 3, that would just be f of 3 times g of 3. F of 3 would be 3 squared. G of 3 would be 3 plus 2. That would be 9 times 5, which would be 45. Important thing to note is that I plugged in 3, the same input, to both functions. Okay. On the other hand, if I look at f of g of 3, well, what I'm going to do here is I'm going to take 3 and I'm going to plug that into g. Now, g told me to take 3 and add 2 to it. So I can say this is f of 3 plus 2, or f of 5. But notice, that means I'm now plugging 5 into f. So the input to each of these 2 functions is not the same. It's the output from g that becomes the input to f. And so f was my squaring function, so this would be 5 squared, which gives me 25. All right, I'm just going to draw a diagram of this. So we said we wanted f of x to be x squared and g of x to be x plus 2, and I wanted to take a look at f of g of x. Notice the way I read that is f of g of x. I read it left to right, but I evaluate it working from the inside out. I start with x, g, which is closest to it, tells me what to do to that. Okay. So here's how I'm going to think of it. I've got this function g, and what the function g tells me to do is take my input and add 2. So I'm going to take my initial input, plug that into g. That's going to spit out some number. I'm going to plug that into the f function. And the f function tells me to take my input and square it, and then that'll spit out my ultimate output. So we just did this with 3. We said, let's take our 3, let's plug it into the g function. 3 plus 2 gave us 5. So then we plugged 5 into the squaring function. So the output from g became the input to f, and that's what gave us our 25. Okay. So that's how function composition is going to work. Let's just make a note that the order in which we do things makes a difference. let's say I wanted to do g of f of x. Actually, let's do g of f of 3, since we just did f of g of 3. So, I would be doing the f function first. That's my squaring function. And then I would be doing the g function. That's my input plus 2 function. So if I took 3 and I plugged it in, 3 squared would give me 9. That becomes my input to g, and 9 plus 2 is 11. So that would be my ultimate output for that particular function. Okay. So let's just practice with a few more. I've got two functions f and g up here. Let's let h of x be 1 over x, and let's let k of x be the square root of x. Okay. So what I'd like you to do is evaluate for me h of f of -2 and k of f of -5, and let's see, g of h of 1/2. Okay. So go ahead and pause this video, work these 3 problems out. We'll start at the beginning of the next section by going over these 3 problems together.